And so I've had a lot of people come up to me. They've asked, is there a better way for us to analyze all of this data? Yeah, there's a ton of good ways to make some better code to get your analysis streamlined. All right, so originally I didn't anticipate one person analyzing 100 data sets. I anticipated everybody doing their own scripts and or at least doing their own analysis. But there's a couple things we can do. We can say close all here, and that's going to close all figures. So every time we run this code, it's going to close all of our figures. That'll help us with extra clicks. Okay, so what else can we do? Well, this whole load function takes a long time because we gotta come in and select this, rename, highlight it, copy it, paste it here. So instead, we can do something called UI get file. So if we type that in, help UI get file, we get this information that says, hey, we're going to open up a dialog for the user to get back a bunch of this, a bunch of these files, and we're going to put those files into an array called file name, path name, and their index. Where they're listed on that folder. Okay. So how we use this, we can just delete this now, or move it. Right. We can say file name. Or even better, we could just come down here to one of their, their examples and just say, hey, let's pick this up. And it's actually typically what I'll do is I'll just pick this up and move it, and then modify it. Right. So it's just here. All right, so the first part, right? The first thing you enter is this this thing that says let's filter it. Let's get our filter spec. And if you look at filter spec as parameter, it determines the initial display of files in the dialog. For example, you can filter all files that have .m. So some file name that ends in .m, and our files end in .mat. So we want star.mat. So we want to filter out all the files that have star.mat, right? There's a couple things that we want here too. If we look down this and read this whole thing, we want multi-select. So we want to select a lot of files at once. Let's turn that on. All right, and then that's pretty good. File name, path name equals UI get file, this stuff, right? So if we want to run that real quick, let's see what we get. Run this. Okay, so it's going to be in my current folder. It's going to navigate to my current folder, and I can select all these files. Let's open that. Okay, and then what I get back is this file name, path name. So path name is this string, right? And file name is this array of cells. So, from our previous videos, we know how to work with that kind of stuff. So, if we want to grab a specific file name, that's just fn equals file name of curly, right? Because this is we come over and now look at this. This is 1x5 cell, and these are cells. So if we want to grab one of those things out, we need the curly brace after file name. Let's just call that I, or let's call this J actually. So then say J equals 1, and then let's see what happens if we just run that, all these files, and we get back, okay, P1 walking hand R. Okay, That's pretty cool. So if we wanted to just have one script that, you know, we can navigate to any folder, we need to have either all of our files accessible by MATLAB, which means, you know, you add the path or whatever, or you could do this thing where instead of fn is just equal to the file name, we could do a function called full file, and full file is going to take in a path name and your specific file name right there, and it's going to spit out a string that is basically the location of that file in your computer. So it's going to say, let's concatenate, let's take the path and the file name together, right? If you do that, then basically you're always going to be pointing at the right file. So that's a pretty good one. So then all we need to do is load fn. All right, so load whatever we did here when we picked all of our files. Okay. So what else can we do? Let's come down here and plot. That takes a lot of time, right? Because we got to plot this find peaks. We got to change MPD all the time, replot, rerun. That can take a long time depending on how good you've gotten at this. So I want to do this new thing for y'all. It's called input. So we can change MPD from a number. We can just say input, and then we give a prompt to say, tell the user to select a number, a value for MPD. Okay, that's all you gotta write. And now if you run this whole thing, right? Also, if you want to run all the way to a certain point in your code all the time, you can just make these double % signs, and this whole thing becomes a region. And then it says run, or a section. And it says run section. All right, so now now it says over here, it's plotted this for us, right? But I want to, it says select a value for MPD, and if I write 80, you can see that plots this for us. So that's nice. We don't have to come in and change our code all the time. But could we do something better? Probably. So let's keep that there so that you can get an idea for what you want for MPD, and you'll get better and better at selecting the correct value there. Let's put a space there because I don't like select the value for, I don't like to have that number without a space. So let's say like colon something, right? So select the value for MPD. Okay. So we can also do this other thing where we say, well, you know, part of this whole deal, right, is that we run this, we select a good value for MPD, and then we selected these points. We read 92 to 1426, and then we typed that in here, and that took forever, right? And it's like, it's a hassle, blah blah blah. We want to do that programmatically. So let's try something. There's another function calledginput. So we can go to help. Let's just look at ginput. So this says that if you have some kind of plot, if you have an axis or figure, and you select something on that figure, it'll return the X and Y values. So X and Y is returned for some amount of clicks that you put on the plot. So let me show you what that means. So let's go say crops, because this is my crop points on the x value, and then the magnitude of acceleration is the y. So then that equals g input, and we want 2 points to gather, right? So let's see what happens if we run this. So if we run this, we get that plot. We can kind of look at this and say, oh, that looks like an 80 MPD. So let's try 80. Oh, it works. Now if we look at where we're hovering our mouse over the plot, if I select a point here and a point here, you can see that it goes away and then it moves on with the code. So let's see what we just did. Well, we selected this point's crop, right, which was 89.06. This is basically a location on the plot. Okay. So we want to make that programmatic. We want to put this crop stuff that we just selected, you know, with our cursor, we put it here. So we say, okay, well, I can't, if I have to have a integer here. So what I first have to do is say round, and then I can say crops of the first data point, right? That's the first region. That's where we start our crop. First, the 89. So if we round that to, it would be just a number 89. And crop end would be round of crops to. All right. So crop end, crop start, crop end, we're good to go. That comes from this G input. And we don't use mags. So sometimes if you don't want the extra variable laying around in your workspace, you can just put a tilde, and that says don't give me anything back from that function. Okay, so let's go ahead and run this. I grab some of my files. I run this section. Looks like an 80 MPD. Okay, select my points here and here. All right. So I get my crop start. Actually, let's run this section here too. So I got my crop end and my crop start. I found that all pretty fast. Okay, and then we did this, we found peaks from AMAG cropped, from AMAG that we cropped, and then now we find our locations and our peak values. Then we can extract our data from that. So if I ran this whole thing now, right, run this whole code, select my data, 80, select my points there and there, spits out my answer and saves my data. So that's nice. But you can see that it doesn't work out too well because now we got to change J. We always got to come back and change these files. So let's go ahead and make that a for loop. For J equals 1 to what? How many things do we want to loop through? Oh, we want to loop through all the file names we have. So let's go numl file name. Okay. And let's save all that stuff every time. Okay, numl file name, J equals 1 to then. Sounds good. All right. We're going to save it as a different thing every time. We got to do that. So, and let's take our file name, just like we do here, file name of J. I'm going to say like save name is equal to that file name of J. Okay. So then here we can do just like we did before, where we said our file name will be our save name from end, or from 1 to end minus 4, right? Because that, remember our file name has like that .mat in it. So we say we want everything from P, starting from the first part, all the way to the end minus 1, 2, 3, 4. So take away that period, and we get that file name there. And we want to end that with .mat. So we put this block around it and say .mat. Right, so we're appending this string to this string. So that's what you want there. Okay. There's another issue, right? Is that it's possible that MPD changes every time too. So let's clean this up. Let's let's go ahead and say, put this in a while loop. While continue is true. So if we do a while loop there, what do we want to loop through? We want to loop through these MPDs and finding those peaks and making sure that that's all good. And then if that's all, if the MPD was good, then we want to start the crop, right? So let's say this is MPD input, so we're just going to keep getting these inputs. Then we want to know if it's going to be a good MPD or not. So then we can say continue, and then 1 is true, so So 1, if it's true, if continue is true, then it comes back up and says, let's do this again. So 1 means no, and 0 means yes. So if cont, right here, is equal to 0, it'll come back up to the top of the while loop and say, oh, it's false. Okay, let's move on to crops with G input. Right? So now let's run this. And I'm going to do what's called run in time. So I'm going to run all of my data that is my raw. Oh, I didn't specify. I gotta start off with a condition. So I can say, just say equals 1. You can either write true or you can write 1. Let's run in time this. Select my data. Looks like an 80. Let's say it looks like a 40, or I'm mistaken. That doesn't look like what I want. So I want to continue. No, don't continue. So select another value. Let's go 80. Oh, that looks good. 0, yes. I'm going to select my points here. Okay. And then, all right, so we got an issue because the data that we wanted got flooded there. So what we have to do here now is actually close all figures here. Close all up there. All right. So if we do that, then every single time we run through this loop, we'll start fresh. Okay. Finally, let's do this run in time. See how long it takes us to do this analysis. Wow, what the hell? All right, so don't know. I must hit a key or something. That was weird. So, gotta come in running time. Let's get this data. What is going on with this? Didn't clear. So we can't close all? No. What's going on? Load FN. FN is oh man, dang it. Look, I saved this as that mat, so I was going to save the same thing. I did the same thing last time too. Okay, so that just means whoops, I can't select the first one. Okay, so let's go. We might have made a mistake. It was 40. Let's continue. No. Let's go 80. Looks clean. Continue. Yes. Select my points. Cool. Let's do it again. 80 seemed to work last time, so it'll probably work this time. Well, I don't know. There's a little peak there in the middle of each. Yeah, it seems to work. 80 seems to work, so say yes. And I want to select from here to, like, I don't know, here. Okay, so let's see 80 again. That works. I like that one to that one. Yep. There to there. Okay, cool. Looks like we're done with our code. And that took us, the whole thing took us 50 seconds, or no, 75 seconds to analyze a whole section of our, our lab's data. So that was five data collection whatevers. We analyzed it all in about 75 seconds. I think that's good. I think you can run through 100 data points no problem, right? All right, so that's the code. Going through it one more time. Clear everything. We get our UI get file. The filter that we want is a .mats, right? Multi-select on. We go for loop through all of our file names. And how many file names? We got numl file names. Now let's extract the file name from, or a full file path here. So let's concatenate path and some file name into fn. Let's load fn. We know that that comes in as Excel, Angular Velocity, Mag. They come in as these variables that will always overwrite each other. All right, so then we can extract that stuff consistently. It's pretty good. We go ahead and plot. We estimate ourselves an MPD. We keep going through this loop, while loop, back and forth, selecting new MPDs from the input. And if we want to continue, then we press 0, and then we continue. In the plot, we can select the two regions that we want to crop. We go crop start is the first crop location. We round that, and then crop end is the second crop location we choose. We round that. we crop all of our magnitude and time data. Go ahead and find your peaks, get your locations, use that to take all your periodic data together into these cells. And finally, we take the save name and we save that stuff. So make sure you put underscore analysis at the end so that you're left with the raw data as it is and also some analysis. Good. I think that's going to work out really well. And you can imagine using the same kind of ideas for all your plotting functions later too. Cool. All right. Good luck.